All right, so I already had an intro, so I don't have to talk too much about myself, but this is the team of engineers that I lead at Formlabs. Like we just said, we're working across a lot of different disciplines. We do kind of soup to nuts on our products, from initial designs all the way through manufacturing, and the Fuse one is no different there. So before I dive into our SLS product line, I want to talk a little bit more about Formlabs as a company. You're probably familiar with Formlabs if you're here today. We're a pretty well-known 3D printing company in the area. We're most well known for the Form 2 line of products that we came out with. This is based on our desktop stereolithography system, the Form 1, that was launched on Kickstarter a few years ago. That's morphed into this product line that you see here. There's a printer, materials, software, accessory kits with the Form Wash and the Form Cure, and that kind of allows us to do all the stuff that we do as a company with a desktop line of our products. So, you might know about our products, but you might not know that we have more than 25,000 3D printers in the field today. These numbers are as of this past summer, and they've only grown since then. So lots of people using our products. Those customers have printed more than 10 million parts on the Form 2, so it's definitely gone from something with a small user base to something that's being used to do a lot of different parts. So these are really getting close to sort of rapid manufacturing kind of numbers with the system, which is why we introduced a few other products that I won't be talking about today. Formlabs as a company, we have about 325 people. We have offices and factories all over the world. We have over 60 partners that are helping us sell and service our machines in 40 countries, so it's really a global brand at this point. And then, finally, the thing I'm going to talk about today is the engineering team that we have and the work that we do across both stereolithography and selective laser sintering. Our engineering team, like I said at the beginning of the presentation, they work in a lot of different areas, but the three main things that go into our products are hardware, which you see here. It has to do with everything from the mechanical engineering for the devices to designing, laying out the boards, getting those produced. We even design our own optical scanning systems for the Form 2. So those are galvanometers. Those are the mirrors that steer the laser on the surface of the bed. We do that in the same factory as the Form 2. So we really try to get in as much detail as we possibly can when we're building our hardware. On the software side, we build embedded software that goes on our machines. We build Preform, which is the desktop software that our users interact with to prepare their parts to be printed. We have our own slicing system that we've developed internally for parts. And then this is a picture of Dashboard, which is an online printer management tool that our customers can use to track the status of their printers and see the statistics of their usage over time. And then finally, and maybe most importantly, we have materials. We have a team of over 20 materials scientists at Formlabs who are developing brand new resins all the time. So far, we've come out with a range of standard materials, engineering resins, jewelry, and dental resins. And all of these materials, the variety of materials you can get with stereolithography really leads to a lot of the interesting uses of the tool. Because at the end of the day, 3D printing is about the parts that you get. And the better materials you have, the more interesting things you can do with your 3D printer. So all those things, the Form 2 hardware, the software, and the materials that we've been working on kind of came together to, I think, really realize a dream that we set out with. I say we, I wasn't with the company at the time, but when the company was founded, the goal was to get closer to this dream of printing with 3D parts the same way that we print with paper. And I think that the Form 2 has really gotten us very close to that at this point. I can go and 3D print just about anything, any shape that fits on the platform with very little fuss and little trouble. And Formlabs could have just kind of settled for that and said, we make desktop stereolithography printers and we'll keep improving this product line. But in 2014, the co-founding team and the board was looking at what could the future of Formlabs look like. And to do that, they started looking at the 3D printing landscape. And so this is a rough snapshot of what we thought it looked like at the time. So you have stereolithography in one corner where you have high quality parts with a lot of detail. But those are mostly used in rapid prototyping applications at the time. And then you have things like PolyJet and FDM, which are also both mostly prototyping technologies. And then you have selective laser sintering, which has good detail, not quite as good as stereolithography. But those parts are being produced in much larger quantities. A lot of the press that we see about 3D printing in the mainstream media usually is about a selective laser sintering 3D printed part, if not a metal 3D printed part, which is another type of powder bed fusion. So selective laser sintering seemed like an interesting option. And when we looked at the landscape of SLS printers, we found that it really looked a lot like the landscape of computing in the 1960s. You have large, expensive machines that exist in a dedicated room that can only be run by specific operators with a lot of training. And it's just sort of an impenetrable space that's really locked off for most engineers and designers and people working in the field. So Formlabs, wanted to ask ourselves the question, is it possible to make a selective laser sintering printer, at a fraction of the cost of the existing technology and make it much easier? So I've got a short video here about the Fuse One and how we think we've answered that question.
The way we make things is changing. Engineers and designers rely on selective laser sintering, or SLS, when other materials won't do, when they need the parts to be strong, impact resistant, and stable over time. SLS fuses nylon powder layer by layer. The powder supports the parts, allowing for complex interconnecting designs. Introducing the Fuse One, bringing the industrial power of SLS to the benchtop. With no need for supports, multiple models can be tightly packed into your build. You can also add parts to an active build so that you can iterate faster than ever before. A live video feed lets you monitor progress and performs real-time inspection for better part quality. The Fuse One is a workhorse. Minimize turnaround time by swapping out the entire build chamber when your print has finished, allowing you to immediately start the next print. Fuse One, putting the means of production in your hands.
So that's the Fuse One. That voiceover is actually done by one of our electrical engineers, Scott. He kind of stole some of my thunder for the rest of the presentation, but I think that hits on some of the high points that we think are important with the Fuse One. It's a powder bed fusion technology, so you take layers of, in this case, nylon plastic in small particles. You spread that out over a surface, and you heat it up to just below the melting temperature, and then a laser using the same scanning system as what we have on the Form 2, strikes the surface, draws the layer, and then fuses those particles together. And that creates one layer, drop down, repeat that process over and over again to get your part. And the parts that are produced with this process, since they're nylon, they're really strong, they're really resilient. You can drop things off of counters, you can put parts into environments that you wouldn't normally want to put 3D printed parts in due to the fantastic properties of nylon. And one of the projects that an engineer at Formlabs undertook with the Fuse One was actually printing his own bike pedals. So these aren't terribly different from any normal bike pedal you might see out there. They're not topology optimized or anything like that, but our engineer Luke actually rode to and from his apartment to the office every day for months on end with these pedals with no problems. And so no problems, holding up to the wear and tear of a biking commute here in Boston, which is, I think, saying a lot if you're from the area. And since the parts that are printed on the Fuse One don't have any support materials, they're just supported by the powder that's not fused together, you can create some really interesting geometries with selective laser sintering that are difficult, if not impossible, with traditional 3D printing methods like stereolithography or FDM. You can create undercuts, overhangs, and really small detailed parts with SLS that aren't available with other technologies. You can even create sheets of this material that are these like tightly interwoven chain link systems. But you don't just have to print a sheet of this material, you can actually print an entire object out of that with no more difficulty than just printing a single sheet. So this is a 3D printed shirt that the team at Nervous System, which is a design studio over in Cambridge, designed for us when we launched the Fuse One back in June. And this shirt has 11,311 individual links. And that's kind of interesting. I think it's a bit of a gimmick, but at the same time, that could be, 5,000 individual parts. They could be small parts, but they could be custom for some specific application. And all of that could fit in one build volume for the Fuse One. So really interesting applications become possible. And you can do cool things with SLS printing, like fold that shirt up into a ball and stick it inside virtual build volume. And then that is the STL that we uploaded onto the printer and ran. So really interesting kind of packing and nesting opportunities there. We built 3D packing into Preform itself. And so users of Preform, which is a free software that you can download right now, when the Fuse One is shipping, you'll be able to get a version of that software that automatically nests and packs parts into the build volume for more efficient printing. So that's, kind of the Fuse One capabilities in a nutshell. It's a quick snapshot. And I'm going to use the rest of my time, which I promise will be brief since I know I'm standing between you and the reception, to talk a little bit about the goals that we had when we were developing the Fuse One and how we decided to go about tackling those things. So the two things we really wanted to think about were reducing the cost of SLS printing and simplifying the system so that any engineer could interact with an SLS printer. So when it comes to low-cost SLS, we looked at the major cost drivers for traditional SLS printing as our starting point. And there are a lot of things that contribute to the cost of SLS printing, but I think the size of the machines, the limited quantities that those large machines are made in definitely help increase the price of the machines. The really expensive high-end lasers that are typically used in these printers, and then also the requirement for an inert atmosphere are things that, it starts getting a little technical there, but they are needed in most traditional SLS printers. But as we kind of went back to the first principles and the basics of SLS printing, we discovered that you don't really need this certain kind of laser if you end up using material that has been darkened or colorized to absorb a different wavelength of material, which is why most of the parts that you're going to see off of the Fuse One are going to be that dark gray color instead of the traditional white color. So that reduces price quite a bit. And it's a trade-off that most users seem to be more than happy to make. The other one is the size and the quantity of the machine. And we think that by shrinking that down substantially and producing a lot more of them, we'll be able to reduce the individual cost of the machines, which is pretty classic. And then finally, inerting the atmosphere is something that has to do with the degradation mechanics of the material. And one of those degradation modes is actually discoloring the material. But since we're already darkening the material, that discoloration isn't as big of a problem. And then, we also are not having as large of a quantity of material at temperature for as long of a period of time, so there's not as much oxidization or thermal degradation happening. So just by shrinking the size of the machine and rethinking some of the first principle approaches, we're able to really reduce the cost of the system. And part of the thing that led us to this approach is what we did with the Form One. So the Form One, took what at the time was probably a $50,000 or $60,000 stereolithography system and shrank that down and simplified it into $3,500, I think was the price of the Form One when it was first shipping. And that was done by stripping out everything that wasn't required to print a part on the system. And once we understood what was needed to make a really high-functioning printer, we added some more complexity and built the Form Two. But we didn't start with all the parts in the Form 2 in the Form 1. So we've taken the same approach with Fuse One development, and our goal is to have the Fuse One that ship speed just as reliable as the Form 2. So we have to kind of go through the entire Form 1, Form 2 phase to develop this product. And to do that, we kind of looked at all the theory and looked at all the first principles, but instead of just getting mired down in analysis, we actually built a really rough initial prototype. So this is not something that Formlabs typically shows. Most places we show off our final finished products, but this is kind of the raw, real deal. This was built by myself and another engineer in what used to be a kitchen at our headquarters. This is a cabinet with a bunch of off-the-shelf components and a few older prototypes of Form 2s in there, and a lot of duct tape and silver tape and everything else that we could get to throw at it to make parts. And even though this looks really bad and the parts weren't that great, it proved the concept that you could build a small-scale, inexpensive SLS printer. And our next prototype was able to deliver parts like this, which wouldn't be excited about showing these off to you today compared to what we can do on the Fuse One now. But at the time, it was a really amazing proof of concept because we used a laser that was the same performance as a laser. We could do it quantity. We didn't have the inner atmosphere. We had a smaller machine. We had kind of ticked off all these boxes. And from there, it's been a lot of development work to get to where we are today, but much more, understandable and plannable kind of stuff ahead of us. And now, we can produce really great parts. So there's a few of these parts that are out in the exhibit area. I'd love for you to stop by and take a chance or take some time to hold them and touch them and see what we're able to do with the Fuse One. And then, we have the machine available from about $9,999, so under 10 grand. You can reserve one today. I probably should make that plug. All right. We can also simplify SLS as kind of our second major goal was to make the machines easy enough that engineers can work with them. And that was done by approaching this a little bit differently because we could talk about user interfaces and the machine, touch points and all the things that We spend a lot of time and attention on at Formlabs, but at the end of the day, if the machine doesn't deliver the result that you expect, it's not easy to use. You have to go through a lot of troubleshooting steps. So we spend a lot of time failing with 3D prints in order for our customers to not have to go through that same process. So, this is just one quick snapshot of 3 different modes of failure that you can have with SLS printing, from the bed temperatures being too hot or too cold or the wrong laser power or whatever it might be that causes everything from small failures to catastrophic failures on any 3D printer. And by systematically going through these failure modes, understanding them, root causing them, and getting rid of them, we're able to deliver a simpler SLS printer than I think anyone else has ever done in the world. And once you get to that level of reliability, you can start thinking about using the technology in different ways. So this is a coupling spot that attaches a stepper motor to a turntable in the Form Cure. This is a product that we make to complement the Form 2. And it's a small part, but as we were prototyping the Form Cure and using the Fuse 1 to do some of that prototyping, we started looking into unit costs, and we discovered that if you have a reliable SLS printer that's low cost, and you amortize a bunch of different things, and you think about the operational costs, you can actually get to a point where you're able to produce multiple thousands of these small parts easily with the Fuse 1. And it's actually enough that you might even think about doing an entire production run of a machine like this, or the first production run, without using an injection molded tool at all. And I think that kind of pushes us in the direction that I wanted to go when I first joined Formlabs, which was taking 3D printing from the prototyping space into the rapid production space. And that's what we're hoping to do with the Fuse 1, as a lower cost, more accessible, easier to use 3D printing system. So I think that's the end for me. Yeah, that's my last slide. I think I have like 4 or 5 minutes, so instead of drawing that out, I will close there and say thank you for your time, and I'll be at the reception. Happy to talk with you more there. And yeah, thanks for having me.